The owner is correct. According to the National Electrical Code, low-voltage wiring for electric eye sensors that are used to stop the movement of power-operated doors must be installed in conduit. This requirement is found in Article 820.43 of the National Electrical Code, which states low-voltage wiring from sensors to operator controls shall be contained in conduit. The purpose of this requirement is to protect the low-voltage wiring from damage, which could prevent the electric eye sensors from functioning properly and potentially causing injury or damage to property. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for safe electrical installations. It's published by the National Fire Protection Association, or NFPA, and is widely adopted by states and municipalities in the United States. It is important to consult with a specific edition of the NEC adopted by the local jurisdiction. Understanding the NEC is crucial for anyone involved in electrical work, from electricians to engineers to building inspectors. The NEC covers a wide range of topics related to electrical safety, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect advancements in technology and changes in industry best practices. Article 820 of the NEC specifically addresses community antenna television, or CATV, and radio distribution systems. While electric eye sensors for doors might seem unrelated, Section 820.43 addresses the protection of coaxial cables and, relevantly, other low-voltage wiring within these systems. Subsection 820.43 details the general requirements for the installation of coaxial cables. The specific requirement for conduit, found in 820.43 FR, emphasizes the need for physical protection of low-voltage wiring connecting sensors to operator controls. The reasoning behind this requirement is multifaceted. Firstly, it provides mechanical protection. Low-voltage wiring, typically carrying signals rather than significant power, is often thinner and more susceptible to damage than standard power wiring. Exposure to physical stress, such as abrasion, impact, or even bending, can compromise the insulation and conductors, leading to signal loss, short circuits, or even fire hazards. Secondly, it prevents environmental damage. Conduit protects the wiring from exposure to moisture, dust, chemicals, and other environmental factors that can degrade the insulation and conductors over time. This is particularly important in industrial or commercial settings where doors are frequently exposed to harsh conditions. Thirdly, it ensures reliable operation. By protecting the wiring from damage, the conduit helps ensure that the electric eye sensors function reliably. This is critical for safety, as the sensors are designed to prevent the door from closing on obstructions. A malfunctioning sensor could lead to injury or property damage. The type of conduit required is not explicitly specified in the NEC. However, the choice of conduit should be appropriate for the environment and the type of wiring being protected. Common types of conduit used for this purpose include electrical metallic tubing, or rigid metal conduit, or RMC, and flexible metal conduit, or FMC. EMT is a lightweight steel conduit that is commonly used in dry locations. RMC is a heavier gauge steel conduit that is used in wet or corrosive environments. FMC is a flexible metal conduit that is used to protect wiring in locations where it is subject to movement or vibration. Installation practices are also important. Conduit must be properly supported and secured to prevent it from sagging or becoming dislodged. Fittings must be properly tightened to ensure a watertight seal. The wiring must be properly installed inside the conduit to prevent damage. When selecting and installing conduit, consider these factors. Firstly, the environment. Is the area wet, dry, corrosive, or subject to extreme temperatures? Secondly, the type of wiring. What is the voltage and current rating of the wiring? What type of insulation is used? Thirdly, the accessibility. Is the conduit easily accessible for inspection and maintenance? Fourthly, the local codes. Are there any local codes or regulations that specify the type of conduit that must be used? In addition to the NEC requirement for conduit, there are other safety considerations to keep in mind when installing electric eye sensors. Firstly, the sensors should be installed at the correct height. The sensors should be installed at a height that will prevent the door from closing on obstructions. Secondly, the sensors should be properly aligned. The sensors should be aligned so that the beam is not blocked by any objects. Thirdly, the sensors should be tested regularly. The sensors should be tested regularly to ensure that they are functioning properly. It is also worth noting that the specific requirements for electric eye sensors may vary depending on the type of door and the application. For example, doors used in residential garages may have different requirements than doors used in commercial or industrial settings. It is always best to consult with a qualified electrician or door installer to ensure that the electric eye sensors are installed correctly and in compliance with all applicable codes and regulations. In summary, the NEC requires that low-voltage wiring for electric eye sensors used to stop the movement of power-operated doors must be installed in conduit. This requirement is intended to protect the wiring from damage and ensure that the sensors function reliably. When selecting and installing conduit, it is important to consider the environment, the type of wiring, the accessibility, and local codes. In addition to the NEC requirement for conduit, there are other safety considerations to keep in mind when installing electric eye sensors, such as installing the sensors at the correct height, aligning the sensors properly, and testing the sensors regularly. The importance of adhering to the NEC cannot be overstated. Failure to comply with the NEC can result in fines, penalties, and even legal action. More importantly, it can put people's safety at risk. By following the NEC and other applicable codes and regulations, you can help ensure that electrical installations are safe and reliable. This includes proper installation and maintenance of the electric eye sensors and their associated wiring. The specific reference to Article 820.43 FR is crucial for understanding the NEC intent. While Article 820 primarily deals with CATV and radio distribution systems, the principle of protecting low-voltage wiring applies broadly. The NEC recognizes that low-voltage circuits, regardless of their specific application, are vulnerable to damage and require adequate protection. The use of conduit provides a physical barrier that protects the wiring from mechanical damage, environmental factors, and accidental contact. This protection is essential for ensuring the reliable operation of the electric eye sensors, which are a critical safety component of power-operated doors. Furthermore, the NEC emphasis on protecting low-voltage wiring reflects a broader concern for electrical safety. Low-voltage circuits may not pose the same shock hazard as high-voltage circuits, but they can still be a source of ignition if damaged or improperly installed. A short circuit in a low-voltage circuit can generate heat, which can ignite flammable materials in the surrounding area. By requiring conduit for low-voltage wiring, the NEC helps to minimize the risk of fire. In addition to the specific requirement for conduit, the NEC also includes general requirements for the installation of wiring and equipment. These requirements are designed to ensure that electrical installations are safe and reliable. For example, the NEC requires that wiring be properly supported and secured, that connections be made using approved methods, and that equipment be properly grounded. Compliance with these general requirements is essential for ensuring the safety of electrical installations. Therefore, it is important to consult the most recent edition of the NEC and any applicable local codes and regulations before beginning any electrical work. The NEC is a complex and comprehensive document, and it is important to have a thorough understanding of its requirements before attempting to install or modify electrical systems. If you are not familiar with the NEC, it is best to consult with a qualified electrician or electrical engineer. They can provide guidance and assistance to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. Remember, electrical safety is paramount. By following the NEC and other applicable codes and regulations, you can help ensure that electrical installations are safe and reliable, protecting people and property from harm. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before beginning any electrical work. In addition to protecting the low-voltage wiring from physical damage, Conduit also offers other benefits. Firstly, it provides a pathway for future upgrades or repairs. If the wiring needs to be replaced or upgraded, it can be easily pulled through the conduit without having to tear into walls or ceilings. Secondly, it improves the aesthetics of the installation. Conduit can be painted or finished to match the surrounding decor, creating a more professional and aesthetically pleasing look. Thirdly, it provides a degree of fire resistance. Metal conduit can help to contain a fire and prevent it from spreading to other areas of the building. When selecting conduit for low voltage wiring, it is important to choose a type that is appropriate for the environment and the application. For example, if the wiring is exposed to moisture, a watertight conduit fitting should be used. If the wiring is subject to vibration, a flexible conduit fitting should be used. It is also important to ensure that the conduit is properly grounded. Grounding the conduit helps to protect against electrical shock and reduces the risk of fire. The grounding conductor should be connected to the conduit using an approved grounding fitting. In addition to the NEC requirements, there may also be local codes and regulations that apply to the installation of low-voltage wiring. It is important to check with the local building department or electrical inspector to determine if there are any additional requirements. Failure to comply with local codes and regulations can result in fines or penalties. Finally, it is important to remember that electrical work can be dangerous. If you are not comfortable working with the electricity, it is best to hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to safely and properly install electrical wiring and equipment. Attempting to do electrical work yourself without the proper training and experience can be hazardous. It is also worth mentioning that the NEC is not the only standard that applies to the installation of electric eye sensors. Other standards, such as those published by underwriters' laboratories, or UL, may also apply. UL standards provide requirements for the design, construction, and performance of electrical products. Compliance with UL standards is often required by local codes and regulations. When selecting electric eye sensors, it is important to choose products that are listed by UL or another approved testing laboratory. Listed products have been tested and certified to meet applicable safety standards. Using listed products helps to ensure that the electric eye sensors are safe and reliable. The requirement for Conduit in 820.43 FR highlights a key principle in electrical safety: redundancy. The electric eye sensor itself is a safety device designed to prevent accidents. Protecting the wiring that connects the sensor to the operator control adds an extra layer of protection, ensuring that the sensor can function reliably even in harsh conditions. This redundancy is a common theme throughout the NEC, reflecting the importance of multiple layers of protection in electrical systems. Consider, for instance, the requirement for both overcurrent protection and grounding. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect wiring and equipment from damage due to excessive current. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. Both of these measures work together to provide a comprehensive system of protection. Similarly, the requirement for conduit and proper installation practices reinforces the reliability of the electric eye sensor system. The conduit protects the wiring from damage, while proper installation ensures that the sensor is correctly positioned and aligned. Together, these measures help to ensure that the electric eye sensor will function as intended, preventing accidents and protecting people and property. The NEC is a living document that is constantly evolving to reflect advancements in technology and changes in industry best practices. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and compliant. The NFPA offers a variety of resources to help people learn about the NEC, including training courses, seminars, and publications. These resources can help you stay informed about the latest changes to the NEC and ensure that you are following best practices for electrical safety. In conclusion, the NEC requirement for conduit for electric eye sensor wiring is a critical safety measure. By protecting the wiring from damage, the conduit helps to ensure that the sensors function reliably, preventing accidents and protecting people and property. When installing electric eye sensors, it is important to comply with all applicable codes and regulations, including the NEC. If you are not familiar with the NEC, it is best to consult with a qualified electrician or electrical engineer. They can provide guidance and assistance to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. And always remember that safety is paramount.